Hey guys, it's Peter from Third Hour, and I'm about to give you a crash course for Miss Mickelson's test. So grab a pen, grab some paper, and let's get started. First thing you need to know is energy. Energy is the measure of how much work something is able to do. You can find energy in many different forms, such as heat, mechanical, kinetic, light, potential, and many other forms. Energy remains constant but can be transferred to other forms and objects. For example, Newton's cradle. You pull one ball up, you let it go, and energy is transferred all the way through the other balls to the other side. It causes the other ball to enter motion. The next thing you need to know is kinetic energy. The easiest way to describe this is motion energy. Anything that's moving is using kinetic energy. See somebody throwing a baseball? Using kinetic energy. See somebody just walking down the street? Using kinetic energy. Moving on, you're going to need to know gravitational potential energy. It might be a mouthful, but it's not hard at all. It's the energy an object possesses because of its position in a force field. The easiest way to describe this is with Earth's gravitational pull. Anything that is on our Earth is acted on by a force of 9.81 meters per second squared. The next thing you need to know is potential energy. Potential energy exists when an object has mass and a position in a force field, i.e. it's at rest and it just hasn't started moving yet. The easiest way to describe this is imagine a ball just sitting on the top of the hill. It has the potential to move, but it's not going to unless acted on by another force. Two more things and we're done. The next thing is conservation of mechanical energy. The best way to describe this is with the formula K plus E equals a constant. K equals the total mechanical energy, while E represents the energy conserved. There are non-conservative forces such as friction that cause the energy to change into heat, which is mechanical energy at a molecular level. If you were to add these in, you'd see that the total is conserved. These conservative forces are those that store up work done against them and then they just give it back. Like a bank account, you put it in, no interest, it'll just give it back to you. The last thing you need to know is energy conservation, from one form to a completely different other form. To start this, you take an energy source which is transferred into storage. That energy is then lost producing heat, which has many uses. An example of this would be you put gas in your car, the gas is then mixed with air, sparks it, explosion happens, that energy turns into kinetic energy. Well guys, that's all you need to know for the test, so you get out there and you ace this test.